Welcome in the lecture of Civil Engineering Drawing. In this lecture, I will discuss about freehand sketching, projection method, and the last one, drawing standards. First of all, I will explain projection method, then freehand sketching, and then drawing standard. Projection method. Projection method, there are basically two types of projection method that are parallel and perspective, and the parallel is further divided into orthographic and oblique projection, and the orthographic projection is further divided into axonometric projection and multi-view projection. I will discuss one by one each projection. First of all, I will explain projection theory, what is projection method, then I will explain one by one each projection method. Projection theory. So what is projection theory? Here is the definition. The projection theory is used to graphically represent 3D objects on 2D media, paper or computer screen. So you may have seen that we can draw different types of objects in the computer. So how we do that? We basically draw the 3D objects on the 2D media here most of the time. For example, here is the 3D object, and for example, here is an observer or a person seeing this object. Then the person can see the shadow of this object on this wall. So this is called the shadow on the other wall, okay, on this wall, that is called projection. Okay, or you can also see if there is a lamp or light, and then the shadow of this object on the wall just like will be the object that that is the 3D object. So this is the projection of 3D object on the 2D media. So that is the projection theory, and the projection theory is based on two principles, two variables. One is line of sight and second is plane of projection. Okay, here you see here is a line that is touching, means that is hitting to the wall, again another point, that are the lines. So in the projection theory, one important thing, that is the line of sight, and the second is plane of projection, and on the screen where the projection is forming, that is the plane of projection. That are the two basic principles of projection theory. So I will explain one by one again the principles. Line of sight. Line of sight is an imaginary ray of light between an observer eye and object, mean between the person and the object. There are two types of line of sight, parallel and converge. Okay, here first of all parallel. Okay, here all the lines exactly coming at the exact locations, means parallel. Okay, the second one is the perspective projection, that is also called the converge. Okay, if the person is saying near to the object, okay, and watching the object, then this will form, and if the person is standing far beyond the object, then these lines will be parallel. So now that are the again, this is also line of sight, this is also line of sight. Here all the lines are converging at the point, here all the lines are parallel. Now the plane of projection, and now I will combine the both line of sight and the plane of projection. Plane of projection is also an imaginary flat plate, a plane which the image is created. On the screen is the imaginary plane on which we create the object. So first of all, parallel projection. Here is a screen, that is we imagine that how the projection of this object form on the screen. Okay, so let's see here. First line of sight, second, third, fourth, fifth, all the line of sights are hitting to the plane of projection. So now the image is produced by connecting the points where the line of sight touches the projection plane. When this line of sight touches to this plane of projection, we will join these points. That is the example of parallel projection. Now let's see the perspective projection. Here all the lines converging at one point in the perspective projection. Second, third, fourth, fifth, now joining by these points. Here you got the perspective projection. What are the advantage and disadvantage? In the parallel projection we get the exact dimensions, means exact shape, exact dimensions. In the perspective we do not got the exact dimensions. The object may be distorted or got some smaller dimensions. Here is the disadvantage of perspective projection. Here is a perspective figure. Perspective projection is not used by engineer for manufacturing of parts. Why? Because these do not give the exact dimensions. For exact dimensions you have to use the measurement tape from this side to this side, and comes at this point in the parallel position, comes at this point in the parallel position, then you will get the parallel projection dimensions. In the perspective, in this figure, if you measure the this width, you will be unable to measure the width of this rod. So it is difficult to create. First of all, it is difficult to create. Second, it does not reveal the exact shape and size. Here width is distorted. Now what is oblique projection? Oblique projection of an object may be obtained by projecting the object with parallel projection. Means its front face is parallel. So first of all, here that is the front side of this object, and the other dimension is extended outward. Here again, that is, for example, the other dimension, that is if that is this dimension is 3 inch height, 3 inch width and 3 inch height, and this dimension is, for example, 4 inch. Then if it is extended to up to 4 inch, then that is on full scale, and if that is extended to 2 inch, the actual dimension is 4 inch, that is half scale, and this is half to full, means in between. So in oblique projection, the front face to object in the true size and shape, mean this dimension, the front face, width and the height and the circle diameter gives the exact dimensions, but the third dimension is not the exact, as it placed parallel to the picture plane. Means front plane is the parallel projection, but the third dimension we extend outward. Now the orthographic projections. Orthographic projection is an parallel projection technique in which the parallel lines of side are perpendicular to the plane of projection. Again the same example. This orthographic projection are the subcategory of parallel projection. So here this is the this plane is placed in front of this plane of projection and the top view. And again here, when we see these two objects from the top, okay, here is the plane projection, then from the top we will see this side and this side. Here first point in the top, here is the first point, second point, second point, third point, third, here also fourth point will become at the same location, and the fifth point again comes at the same location as that of 1. So now join these lines. So that is the orthographic projection, means the line of sight are perpendicular to the plane of projection. Orthographic view on relative position of the object to the line of sight. Here now I will change the relative position. There you will see a new thing in the orthographic projection. Here the line of sight hitting to the plane of projection, the same object is formed. Two dimensions of an object is shown, means this width and height is shown, but this length is not shown in this orthographic projection drawing. Okay, so for this top width and length, we have to draw another projection by placing the plane of projection at the top. For fully understanding of this object, means we need one more drawing. This is the one drawing we are showing the width and height, and we need another drawing to get this dimension, the third dimension. So here two dimensions of an object is shown. More than one view is needed to represent the object. Okay, if more than one view is needed, so that is called multi-view drawing. Means we need one more view to draw to get the full meaning of this object, so that is called multi-view drawing. Now the same object just tilted slightly. Again the perpendicular lines are drawn, but this time the object is formed in the 3D. Three dimensions of an object is shown, means you can see width, height and length, all dimensions are shown. That is called axonometric drawing. This will not give us actual dimensions or the exact shape and size, but this will help us in the understanding the shape of the object. So that is called axonometric drawing. Three dimensions of an object is shown in one drawing. Now that is again the definition of multi-view drawing and axonometric drawing, that each view show an object in two dimensions. Means we need more than one drawing. In the axonometric drawing, all the three dimensions are shown in the one view. Both drawing types are used in technical drawing for communication. Means when we draw in the commercial purpose drawings, we need both views, multi-view drawing and axonometric drawing. Here the axonometric drawing type isometric. Okay, isometric when we place the object at 45-degree angle here, and then draw the object. Advantage, we can easily understand that is a 3D object and here is circle is present. Okay, but when we go for the measurement, you in the understanding the 3D object is okay, but when you go for the reading on the measurement, you will see this is an ellipse. Okay, so it means we can't measure the exact dimensions from the axonometric drawing. It is good for understanding but not good for measurements. Okay, shape and angle is distortion. Multi-view drawing, it represents accurate shape and size. Disadvantage, require practice in writing and reading, means need more practice for drawing this multi-view drawing. So here is an object. Now I will draw the multi-view, means more than one drawing. Here you can see the front face and the right side face. The front face is shown here. Okay, there you can see. Now you can measure the exact circle dia, width, height. Okay, here the bottom step. And when I the right side view, here in the right side view you can also measure this width of the object, and this is the height, and where the circle is present, the circle is shown with long dash, short dash, long dash. Similarly in the vertical, long dash, short dash, long dash. That is the notation for the center line of the circle. Similarly the center where the circle is present, center line is shown here, and the upper we know when we see from the right side of this object, we know behind this object the circle is present. To show that hidden feature, we show with dashes, dash, 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 dash. Similarly here. Okay, so here are the dimensions. Now we can locate exact locations, measurements like diameter, where the location is of this circle, that we can exactly and accurately measure in the multi-view drawing.